Welcome students, I am Ravi Shankar. In this video, let us continue the previous concept called to be the eddy currents, and here we are going to study about the applications of eddy currents. See, even though when we are studying about the eddy currents, we have termed as there is some loss in energy due to the formation of eddy currents. The loss in energy, we are calling it out as the eddy currents formed is left out or dissipated out in the form of heat energy. Though the production of eddy current is considered to be undesirable in some cases it is found to be a wastage of energy. But in some other cases, these eddy currents are found to be useful also. So that usefulness of the eddy current is listed out here as applications of eddy currents. What are its applications? Number one, you might have heard about the induction stove. Nowadays, the famous stove, what we are using it in electricity, so called to be induction stove. Induction stoves are working under the principle of eddy currents. Then number two, we can consider as eddy current brake system. The second one is eddy current brake system. You might have seen on roller coaster or trains. In roller coaster as well as in trains, eddy current brake systems are being used to stop that vehicle. Then number three, electro eddy current testing. We are having the third one as eddy current testing. By having any material, if there is any flaws in that material or crack in that material, or if any air bubble is available inside that material, the nature of that defect can be tested with the help of eddy currents due to the change in phase or the amount of EMF induced. And finally, we are calling it out as galvanometer damping. We know a device called to be galvanometer, which is used to indicate the flow of electrical current. So in order to indicate the flow of electrical current, the needle should oscillate. The needle is connected to a cylinder which is oscillating. So in order to bring the oscillating cylinder immediately to rest, we are using this concept called to be galvanometer damping. So in our book, we are being discussed with 4 applications. First of all, let us consider the first application. What is the first application? We are saying it as induction stove. So what is this induction stove? This induction stove is developing a large amount of heat energy, with the help of which we can able to save large amount of electricity. So that with a large amount of heat energy, we can able to cook the food within a short time as well as safely. So induction stove is an arrangement, we can say induction stove is an arrangement using which the food materials or food can be cooked in a short time and safely with less amount of energy. See, you might have seen an induction stove. When you are considering the induction stove, at the top you will be having a platform. See, on the top, let us consider this as the top. See, over that platform, you might have seen some concentric rings to be drawn over it. Over this, you might have seen some concentric circles are being round over the top of what? The top of the platform. You might have seen in your home, or you just go and look it out. That we are calling it out as what? That we are calling it out as the cooking zone. See, when you are considering this cooking zone, below to the cooking zone, see, lower, below to cooking zone, below to this cooking zone, you will be having a coil of wire which is tightly wound on it. So a tightly wound below the cooking zone, you can see a tightly wound insulated coil. tightly wound insulated coil. See, to this tightly wound insulated coil, we are supplying an alternating current. That alternating current means AC current that we are getting in our home. So we are supplying an AC current to that induction coil or insulated coil, which is wound tightly and kept below the cooking zone. See, the alternating current that we are getting in our home is having a frequency. This alternating current is having a frequency in the range of 50 Hertz to 60 Hertz. So the frequency of alternating current is 50 Hertz to 60 Hertz means in 1 second, the direction of the AC current is changing 50 times or 60 times. So due to the change in alternating current, you can able to produce a change in magnetic field. So I can write here, due to change in alternating current, alternating current, a changing magnetic field is produced. A changing magnetic field is produced. See, when you are having that change in magnetic field, that change in magnetic field produces a change in magnetic flux because that you are having an area. See, a suitable pan is being made over which has to be placed over what? Which has to be placed over the cooking zone. Now what will happen? Due to the change in magnetic flux, a current, an induced current or an EMF is induced in that cooking object or in that pan. So that induced current is in the form of circulating current. So that circulating current, called to be eddy current, can able to develop a large amount of heat energy which can cook the food within a short time and also with less amount of energy. This is called to be the working of the induction stove. Here we have to note in practice or in practical cases what they will do. In practical cases, the frequency that was being supplied to the coil, 50 Hertz to 60 Hertz from the alternating current, that is from the source of our home. This frequency is considerably increased to 20 kilohertz to 40 kilohertz, and then it is supplied to what? And then it is supplied to the induction coil. When the frequency of the AC current is increased means, then the rate of change of magnetic flux also changes in a rapid manner. When the rate of change of flux is higher, then the amount of EMF that was being induced or the amount of current that was being induced in that pan or in that cooking vessel is considered to be high. So due to large amount of that induced EMF, which is in the form of eddies or circulating, a large amount of heat energy is developed. That large amount of heat energy makes the food to cook within a short interval of time safely and also with less amount of energy. This is what we are calling it out as the working of the induction stove. Let us summarize. See, what is an induction stove? An induction stove is an arrangement using which you can able to cook the food within a short interval of time. That is, we can able to cook the food fastly and also safely and also with less amount of energy. How this induction stove is constructed? This induction stove is having a top platform over which you might have seen some concentric rings which are representing the cooking zone, after which you are not able to get that. So that the diagram that was being given in the form of concentric rings represents the cooking zone. Below the cooking zone, you see, below to that of the cooking zone, you will be having a coil of wire which is wound tightly. That coil of wire is wound by a thin insulated wires. So thin insulated wire in the form of a coil wound tightly and kept below the cooking zone. To that coil of wire, we have to supply the alternating current or the AC current, which is the source of our home household appliances. So the AC current that we are supplying is having a frequency in the order of 50 to 60 hertz. 50 to 60 hertz frequency means the direction of that AC current is getting altered 50 times in 1 second. So due to the change in alternating current in the coil, you will be having a change in magnetic field. That change in magnetic field produces a change in magnetic flux. That change in magnetic flux is developed over in the pan, which is kept over the cooking zone. So the pan which it develops a change in magnetic field or change in magnetic flux induced with a large amount of eddy currents. That large amount of eddy currents in the pan is converted into a large amount of heat energy which can cook the food within a short interval of time. But usually in practice what we are doing is, that is the manufacturer of that induction stove, what they will be making is, they will be making an arrangement to increase the frequency of the alternating current that we are supplying. The alternating current that we are supplying is increased from 50 to 60 hertz to 20 kilohertz, that is 20,000 volts to 40,000 volts, so that the change, the rate at which the flux changes is high. The rate, when the rate of change of magnetic flux is high, change in magnetic flux is high, automatically a large amount of eddy currents are being induced. That large amount of eddy current induced can able to develop what? Can able to develop or can able to give out a large amount of heat energy with the help of which the food can be cooked within the short interval of time. This is the function or this is the working of what? Function or the working of the induction stove based on what? Based on eddy currents. What is the next one? The next option or the next application that we have to study is the eddy current brake system. So when you are considering this eddy current brake system, we are having two types of eddy current brake system. One, we are considering it as linear type brake system, linear eddy current type brake system, linear eddy current type brake system. Okay, what is the next one? The second method is circular. So circular eddy current, circular eddy current type, circular eddy current type brake system. What is the difference and where are they applied? Let us see. See, first of all, where these eddy current brake systems are being used. I can say the eddy current brake system. Okay, the eddy current brake system or eddy current brake systems are used in roller coasters. In roller coasters, you might have seen in so many exhibitions or in fun places, etc. Roller coasters, and also in electric trains or in ordinary train also, and they are used in electric, mainly they are used in electrical trains. So how these eddy current brake system is working? First of all, let us consider this one, or which one? Let us consider the eddy current brake system, which is linear type. When you are considering the linear type of eddy current system, we have to take strong electromagnets. We have to consider strong electromagnets. These strong electromagnets are fixed to the rails of the rails, or they are being fixed to the rails. If you are considering a roller coaster is running over a rail. If you are considering a train, the train is running over the parallel rails. So on that rails we have to fix what? On that rails we have to fix this electromagnets. Then if you want to make the object which is moving over the rail has to be stopped, then these electromagnets are supplied with a large amount of electrical current, so that the rails will be acting as a strong magnetic field, or the rails can able to produce a strong magnetic field. Over that magnetic field, if the wheel is rotating, then automatically the wheel which is having a particular area will be linked with the flux. Due to the rotation of the wheel, there is a change in flux. That change in flux induces a current in that wheel, but in opposite side direction. So the change in flux and the induced current, which are in opposite side direction, acting as an brake system and not allowing the roller coaster or the train to move. So this system, we are calling it out as linear eddy current brake system. Clear? So strong electromagnets are fixed to rails. Let us consider you are having a rail, and below this you are having a strong electromagnets to be placed. Over this, when you are having the wheel to be rotating, or when the wheel is being placed, and when these electromagnets are said to get magnetized, then a strong magnetic field B will be developed. Due to that strong magnetic field in this area of the wheel, you will be having the flux. Due to the rotation of the wheel, automatically there will be a change in flux. Due to the change in flux, current is induced, or you can say induced current is developed. That induced current makes this rotating wheel to come to rest immediately. That we are calling it out as linear electromagnetic brake system. What is the circular magnetic brake system or circular eddy current brake system? When you are considering circular eddy current brake system, you have to consider the circular disc of the wheel. See, when you are considering the wheel of the train, the wheel of the train is fixed with a circular drum. This circular drum can able to rotate. This circular drum is made to rotate in between the pole pieces of an electromagnet, north pole and south pole. When a strong electrical current is given to this poles of the electromagnet, automatically when you are supplying electrical current, automatically you can able to get strong electrical or strong magnetic field is being developed. So that strong magnetic field will be acting from the north pole of the magnet to the south pole of the magnet. Inside this, when the drum rotates, see, if the drum is rotating in this direction, in clockwise, immediately there will be a change in flux. See, inside this strong magnetic field, if you are having a drum, the drum will have a magnetic flux initially, because the drum will be having an area. Magnetic field into area will be equal to the flux linked with that drum. Now, when the wheel rotates, automatically the flux changes. When the flux changes, an EMF or an current is induced in an opposite side direction to that of the direction in which the flux changes. So the EMF induced is in the opposite side direction, or the current induced in the opposite side direction, which makes the rotating disc to rotate in opposite side direction, so that the moving train will come to rest immediately. A couple is formed. Because of that couple, a torque will be developed, and the torque makes the train to get stopped. You see, you are having a wheel. Inside this wheel, you are having a drum. In this, you are having what you will be having a pole pieces of an electromagnet permanently fixed. One is north pole and another one is south pole. When I am supplying an electrical current, a strong magnetic field is developed in between the north pole of the electromagnet to the south pole of the electromagnet. So because of which the drum is linked with what? Drum is linked with strong flux, Now you consider this drum is made to rotate. The drum is rotating in clockwise, means at this end it is going from left to right, and again at this end it is going like this. Now, due to the rotation of this drum, there will be a change in flux. Due to change in flux, an EMF is induced. That EMF induced will be in a direction opposite to that of what? Opposite to that of the direction in which the flux changes. White color, in white color I have drawn the change in flux, and in yellow color I have given the change, the direction of the EMF or the current induced. See, the direction of current induced in both ends are equal and opposite. They are forming a couple. The resultant of the couple is a torque. The torque is said to get produced in a direction opposite to that of the direction in which the wheel is rotating. So this brake system brings the rotating wheel come to rest position with the help of eddy currents. This we are taking it out as the second application called to be eddy current brake system. An important question which may be asked separately in either 2-mark question or in 3-mark question. Okay, let us go for the third application. What is the third application? Third application, we are saying it out as eddy current testing. What do you mean by this eddy current testing? You can able to test with the help of eddy currents. Is there any flaw or is there air bubble present inside a specimen? So let us consider a specimen. Any specimen that the eddy current can get induced. Let us consider a specimen. See, in this specimen, we have to consider, is there any destructive parts? Is there any destructive parts available in that specimen? Or if it is having any defects on the surface, any defects on the surface, or inside the specimen, whether there is some air bubble, is there any air bubbles available or not? Like this, we can able to decide, is there any defect in that specimen? So for that, what we have to consider, you consider a coil of insulated wire. Okay, you consider a coil of insulated wire. This coil of insulated wire is supplied with alternating current. See, I have given a symbol like this. This represents alternating AC current. So to this coil, I am supplying an alternating AC current. So around this coil, you will be having alternating magnetic field. So around that coil, you will be having alternating magnetic field. Now, when this coil is brought nearer to that of the specimen, when this coil is brought nearer to that of the specimen, that has to be tested. Then what happens to this specimen or to this test surface? Automatically, what is induced? We can say eddy currents are induced. Eddy currents are induced on the test surface or on the specimen. Okay, the eddy currents that are being present in that surface changes if there is any defect or if there is any air bubble or if there is any crack in it. So if there is a change in phase or change in the direction or change in the magnitude of the eddy currents, then we can able to say what? Then we can able to say there is some defect in that testing surface. So how you can able to test? If there is any change in amplitude means magnitude, the value in amplitude or phase direction. So any change in amplitude or phase of eddy currents, that indicates eddy current, then that indicates a defect, indicates a defect in the specimen or in the testing surface. This we are calling it out as the eddy currents acting like what? Acting like the testing purposes or acting for testing purposes. Hope you should have understood. If you are having a specimen and in that specimen, if the surface is whether it is having any defects or is there any crack or is there any air bubble, like that we can able to determine it with the help of eddy currents. For that, what we have to do? You consider insulated wire wound in the form of what? Wound in the form of a coil. To that wound coil, you supply an AC current. due to the supply of AC current or due to the variation in the AC current frequency, the direction in AC current, change in direction in AC current, a large amount of alternating magnetic field is being developed. When that coil is brought nearer to that of the testing surface or to the specimen, and you have to note whether there is any change in the phase or amplitude or in both. You have to analyze whether the eddy current changes or not. If there is any change in that eddy current, then we have to say that the surface is having some defect or the surface may have an air bubble. So that we have to determine it with the help of a separate device. Now, what type of or what nature of the defect is to be available, that we can able to know by studying the nature of change taking place in the testing coil. It is called to be eddy current testing. And finally, we are having the fourth one called as galvanometer damping. What do you mean by this galvanometer damping? Have you heard about this galvanometer? See, when you are considering this galvanometer is a device to indicate or to measure, indicate the flow of electrical current, Also, this device is used to measure current. Also, it's used to measure what? Measure the value of current. See, in order to measure the value of current, when you are considering the galvanometer will be having a cylinder. Inside the galvanometer, you will be having a cylinder over which you will be having a rectangular frame. And in this rectangular frame, you will be having thin insulated wires are being wound and they are suspended from one from a support and another connected to a spring. See, at the center of this coil, you will be having an axis over which a pointer is connected, and this pointer moves over the scale where the value of the current can be marked or calibrated. So how it works? When the current passes through this coil, then we can able to get what? We can able to get the current to be circulating in this coil and leaving out through this. When the current is circulating, a uniform magnetic field is being developed. See, it is placed inside an uniform magnetic field, pole pieces of a permanent magnet. So the current that is passing through the coil inside the magnetic field produces a force called to be magnetic Lorentz force. So the force will be acting on both the coils or on both sides. At one side it is acting away and another side it is acting inwards. Because of these two forces, F, F, on this coil you will be able to have a torque. The torque makes the coil to rotate. When a sudden rotation is being caused, this coil will be oscillating for a long time to come to rest, and we have to wait till the coil comes to rest and show the reading. It is very difficult to wait for an hour or 2 hours in order to measure a very small amount of current. So they are using, in order to bring that oscillating coil to rest, to damp, they are using this arrangement called to be galvanometer damping. What is that galvanometer damping? See, at the center you are having a circular cylinder, isn't it? When the coil gets rotated, then the flux, because here you are having magnetic field, the flux linked with the coil changes, linked with the conductor or with the solid conductor changes. When the flux linked with the conductor changes, automatically inside the conductor an EMF or a current is said to get induced. That EMF or the current that is said to induce is in a direction opposite to that of the direction in which the coil is rotating. So that induced current which produces a torque in the opposite side direction will bring the oscillating coil to rest position immediately. That we are taking it as galvanometer damping. Are you able to understand? See, here I have explained. In order to study, you take your book to page number 223. From 223 onwards, you are being given with the 4 applications till the page number 225. Study it and make it thorough. It will be easier. Okay. Is there any difficulty? See, we are having 4 applications. One, we are saying it as the induction stove. The second one, it is considered to be eddy current brake. The third one considered to be eddy current testing. And the fourth one considered to be galvanometer damping. In order to make the oscillating coil to rest position immediately or to damp immediately, we are using eddy currents. So the eddy currents that are being developed inside that solid conductor, which is in the direction opposite to that of the direction in which the flux changes. The oscillating conductor or the oscillating coil is opposite to that of the direction in which the current is induced. So the EMF induced or the current induced makes the oscillating coil comes to rest position immediately. That phenomenon called as electromagnetic damping. Since this is used in galvanometer, we are calling this as galvanometer damping. Hope you should have understood this concept. Similarly, this question may also asked for 5 mark, or all the 4 can be asked even for 3 mark question also. So make it thorough. Let us meet in our next video. Until then, goodbye. Thank you from Ravi Shankar.